Scene 1, The Corrosion Mystery and Passivation Film Dogma. Welcome to this lecture on electrochemical polarization. For decades, electrochemists and material protection engineers have lived under an absolute dogma, the passivation film theory. According to standard textbooks, when iron undergoes anodic polarization, the current density suddenly drops to almost zero at a certain potential because a dense, protective, nanometer-thin oxide layer, such as magnetite or ferric oxide, is formed on the surface, blocking further oxidation. This passivation theory became the supreme gospel of metal protection. But is this picture physically true? Or have we merely accepted a convenient fiction because we are too lazy to look closer? Scene 2, The Repeated Scan Anomaly. In our landmark paper published in the Journal of Chemical Education, 2013, 90, 76-81, we revisited iron's anodic polarization curves and discovered something extraordinary. When we rescanned the sample immediately, the polarization curve repeated perfectly. Let's think about this with simple, uncompromising logic. If the traditional explanation were correct, if a dense, stable oxide passivation film indeed formed and blocked the metal surface, then a subsequent rescan should show zero or negligible current right from the start. The film is already there, protecting the metal. But it doesn't. As soon as the voltage drops back to low values, the current flows again, and as we increase the voltage, the current climbs, peaks, and gets suppressed at the exact same potential difference. The process is completely reversible and repeatable. This proves that the suppression of current is not caused by the formation of a dense, permanent physical oxide film. It is a dynamic state where current is suppressed by the electric potential difference itself. As soon as that potential drops, the suppression vanishes instantly. Scene 3, Cargo Cult Science in the Lab. This repeating scan phenomenon is so simple to observe that we are certainly not the first to have seen it. Yet, before our paper, there was virtually zero mention of this in the literature. Why? Because of what Richard Feynman famously called cargo cult science. When modern researchers find experimental results that don't fit the established, textbook passivation film theory, they don't question the theory. Instead, they assume they did something wrong in the lab. They think, my cell must be leaking, or my electrode was contaminated, and they throw the data away. They ignore any results that contradict the prevailing consensus, treating anomalies as personal mistakes to preserve the cozy, unchallenged illusion of the textbook dogma. They would rather believe their own hands are broken than admit that the textbook is wrong. Scene 4, The Low Theoretical Level of Academia. This systemic blindness is a direct indicator of the low theoretical level of modern academic researchers. Most scientists today are trained not as independent thinkers, but as high-tech technicians. They excel at running advanced, expensive characterization machines, but lack the theoretical capacity to audit the thermodynamic and kinetic equations they rely on. They run away from raw physics and mathematics, seeking shelter under the umbrella of consensus. Science progress depends on treating anomalies not as errors to be hidden, but as seismic faults that expose the cracks in our understanding. By proving that the anodic polarization curve of iron is fully repeatable and reversibly potential controlled, we have shown that passivation is a dynamic, kinetic equilibrium state, not a simple permanent oxide barrier. We must reject the copy-paste habits of cargo cult science, restore independent, critical auditing to our laboratories, and have the courage to trust our data over textbooks. Scene 5, The Pedagogical Revolution. This work has deep pedagogical implications that strike at the heart of modern academic policy. In Section 3 of our paper's supporting information, we proposed a paradigm shift. The main goal of education is not the premature creation of new knowledge or forcing students to innovate before they understand. Education mainly concerns learning, building deep learning ability, and acquiring the capability to apply existing knowledge to solve real problems. True innovation is not something you can chase by building empty labs and rushing graduate students to publish trash papers just to graduate. True innovation naturally arises when a mind has fully mastered and inherited the greatest achievements of human civilization. When universities prioritize superficial innovation over solid theoretical training, they end up producing millions of paper manufacturing technicians who cannot think. By teaching students to refuse uncritical acceptance and instead verify basic physical principles, we cultivate real problem solvers. Scene 6, Outro. Thank you for watching the lecture of our series, where we expand our critical audit beyond wave mechanics to classical electrochemistry. True scientific craftsmanship means looking at the most basic, common experimental curves with fresh, unsuperstitious eyes. We must stop treating textbook consensus as a divine shield and start verifying physical logic from first principles. Go read Dr. Yulu's original J Chemistry EDUCE paper and related critical treatises on Substack and SSRN. The links are in the description below. Let us break free from the cargo cult, and let logic rule our labs. Thank you for watching.